Hi, everyone. So now we're going to be going through the functional block diagram of the LunaSat. So a functional block diagram, also known as an FBD, are often used to visualize systems. They're great for showing how different parts of a system are connected and how they function. Really shows how everything works together and how everything's connected. So it's really helpful. And in this module, we'll be going over the FBD for different systems of the LunaSat. How to read an FBD. So essentially the lines are connections between components. Lines can be either power or data lines. The power lines are what are used to get power to the microcontroller and the sensors. And then data lines are how the sensors will talk to the microcontroller and send the data back to them, or it back to the microcontroller. Most FBDs are color coordinated. So green is power, blue are the digital sensors, orange are the analog sensors. Purple is a microcontroller, teal is RF, and yellow is bootloading. So over here, we have an overview of the FBD for the LunaSat. So as you can see, the power is the green in the middle. Coming from the power are the green power lines going to the digital sensors, the analog sensors, and RF communication. Data lines, which are the dotted lines, those are going from the sensors to the microcontroller. And then there are data lines going from RF and external communication to the microcontroller, but then also from the microcontroller back to those. So it kind of shows how they communicate back and forth, and then how the two sensors, the digital and analog, will send everything to the microcontroller. It's kind of a more detailed, in-depth version of the functional block diagram. So in power, we have the solar panel, which takes in the power, all the power will go to the PMIC. This will convert it to a working voltage, 1.8 and 3.3. All the voltage will be sent to all the different sensors, which you have the digital and the analog, which can be seen on the right here. And then the power will be also sent to the RF communication, specifically the radio. This communicates with the antenna, which will take RF in and then also send RF out. And then we have the different data lines for the digital. We have the I2C data lines, which will send the data to the microcontroller. And then we also have the data lines for the analog sensors. And then everything on the left here, there's the different SPI communication, but then also code. So this shows how the microcontroller will communicate with the RF systems and the external communications systems as well. So just an overview of the FBD for the magnetometer sensor. Power is handled by the power management integrated circuit, which is the PMIC. All components take 3.3 volts. The different components use different communication protocols to talk to the microcontroller. As we looked at previously, the digital sensors will use the I2C, and the analog sensors will send raw data. The RF and bootloading interface use SPI, and then the FTD uses serial communications via UART. So kind of for the bootloading, looking over the SPI, that's just kind of how we are able to make sure all the sensors are working, kind of test everything. Really, that's how we're able to send code from our computers to the LunaSat and kind of really run functionality testing for the LunaSat. And then just a LunaSat example, this is for collecting temperature from the temperature sensor data. So first we'll program the Atmega, which is a microcontroller, to collect temperature readings from the temperature sensor. Power from the solar panels will flow through the PMIC. The PMIC will output the 3.3 volts to the processor and then the temperature sensor as well. The temperature sensor will send raw data values to the microcontroller through the data line, which, as we saw previously, was the I2C protocols. And then the microcontroller will then decode the raw data. And that's how we're able to really see everything that the temperature sensor is reading in. And then out in the picture here on the right, you can see the temperature sensor highlighted in red. And this is on the backside of the LunaSat. So this is the FBD for using RF, for using the temperature sensor data. So essentially power is taken in through the solar panel, converted through the PMIC, sent out through, as you can see, the power line into the temperature sensor. That'll read in the data, send all the data through the I2C data lines to the microcontroller. And then this microcontroller will use SPI communication to communicate with the RF system, which includes the radio, the SX1272, and the antenna as well, which, as we said earlier, sends in and out RF communications. So this is really how we're able to take in data from the temperature sensor and then use RF to communicate back and forth and read out the data as well. So just a quick summary, functional block diagrams, FBDs, are very helpful in breaking down and understanding your system. You can make a functional block diagram for anything, and they're especially helpful in electronic systems. It really shows how everything's connected, how everything within the system works together to make the system operational. And specifically for the LunaSat, it shows how power is taken in, it's converted, sent to RF, and then also all the sensors, how we're able to read in the data from the sensors to the microcontroller and back out through the RF. And then also how we're able to test functionality through our laptop and the SPI interface. So really just shows how everything works together and how the system is really able to operate successfully. Thank you.